This is 8th grade math. We're talking about accuracy in math and science. This is a review video of some topics that we've covered that we're going to continue to apply in class. Please make sure you add these to your notes and that you understand what it is we're talking about. These are some things to think about when we're talking about accuracy, both in math and science class. And I want you to see them so that you can write about them for your communication criteria. Okay, first of all is scientific notation. We've been studying scientific notation. You know what scientific notation is. It's used for writing very large and very small numbers. Something to look at in both math and science is, are they using scientific notation correctly? So, for example, are they writing it correctly? Is this correct scientific notation? No, of course not. Scientific notation would always be one digit, then the decimal point. If we were to correct this, this would move one place this way. It would be written as 1.0 times 10. And what do we do with our exponent there? It was to the -4th when we moved it this far. I need to move it one more place that way, which means it's going to become to the -5th. Or, does it even make sense to use scientific notation? For example, here's 2.0 times 10 to the 1st. Well, 10 to the 1st would be 10. 2.0 times 10 would be 20. Would I bother writing it out for something that's really just 20? No, that's not too large or too small to be used in standard form. So scientific notation, are they using it correctly? And does it make sense to write that number in scientific notation? Something else to think about is the audience or the context that you're using when you write your numbers. So if we're talking to scientists, then use scientific notation, absolutely, if it's a very large or small number. If it's something like 20, you probably don't need it. If you're writing to a newspaper, you're going to want to use word form. If it's a question where they're asking about how much, then they're asking for a rounded form. They're asking for an estimate. They don't want an exact answer. If you're reporting time, you're always going to use standard form. We never write time in scientific notation or in any other form. Something to think about is consistency. When you're working in math and science class, you should be using the same units throughout. So, are you using milliliters the whole way down? Or did you switch to gallons? Are you using liters, or did you switch to something else? Look to see if the same units are being used. And last but not least, something to think about are that there are consequences to being inaccurate. And those consequences are different depending on our context. So if we're doing a science experiment, we may have an invalid science experiment if our numbers are not accurate. If we're in math class, maybe we have a wrong solution. If we're doing something like measuring out medication, we may end up with a dangerous amount of medication. If we're doing something like figuring out the amount of fuel I need for a plane, I may end up with an unsafe situation. So it's important to recognize that there are real-world consequences to being inaccurate. These are the types of things that you're going to want to be able to look for and talk about when we do our work in class.